Hi, good morning everyone. Yep, AM WA is coming soon, and here are today's video. We're going to go through two out of the few revision sets that we have. Okay, so we are going to look at the first two sets. Okay, and I'll just walk through everything with you. So it would be good if you have like a list of law of logarithms and also your the binomial theorem results and formula with you. Okay, and yeah, so we'll just do this together. Okay, so find, okay, revision set 1, question 1. So find in ascending powers of x, so means that the, okay, more like ascending powers of p. Okay, typo, the first three terms in the expansion of 2 plus p power 6. So when you do this, right, the first thing is please do not do this. This is completely wrong. Okay, cannot doesn't work this way, because even this, right, you have the a square, wait, okay, even for square, right, you have a square plus 2ab plus b square, right? So this one you better not do this kind of mistake, right? So the purpose of doing binomial theorem is because you are expanding to a series of polynomial. Okay, so the first three terms in the expansion would look like this. So I will start with okay, so 2 plus p power 6 is going to be equals to, now I will keep running n choose r. Okay, so this will be 6 choose r, a to the power of n minus r, and b to the power of r. So the r I start with 0. Okay, let me just copy and paste this. Okay, copy. Okay, let's see. So 6 choose 0, r is 0, r is 0. Okay, so plus. Okay, ah, okay, second one. So 6 now is 1, 1 and 1. R is 1. Okay, so copy and paste again. So this one will give me like this. Right, so now is 2, 6 choose 2, n minus 2, and 2. Okay, so we only need the first three terms, so it will be 0, 1, and 2. Okay, all the way until 6. So in total, we have 7 terms. So please don't just do the 2 power 6, p power 6. Doesn't work that way. Okay, you have total of 7 terms. Okay, so let's do this one by one. So 6 choose 0 is 1. 2 to the power of 6 is going to give me 64. Right? Then p to the power of 0 is 1. Okay. 6 choose 1, you type in your calculator, should be 1. 2 power 5 should be 32. Then you have a p power 1, like that. Okay, so I'm just going to write this as p. Next one, 6 choose 2 should be 15 in your calculator. Then 2 to the power of 4 is going to be 16. Then p squared would just be p squared, and so on and so forth. So just nice you see the power of p from p power 0, p power 1, p power 2. So indeed it is in ascending powers of p. Okay, so next let us simplify. So 64 plus, okay, 6 times 32 will give me 192. 15 times 16 will give me 240 p squared, like that. Okay, so this would be the first answer for the first one. Now second one, so hence find the coefficient of x squared in this. Okay, so hence find the coefficient of x squared in this. So what we want to do over here is we want to draw parallel. We want to compare and see, because it's hence, right? So we need to make use of the front portion. So if you notice, this is 2 plus p. This will be 2 plus this whole thing, right? So technically, right, p is going to be equals to this, if you notice carefully, right? So what can you say over here would be, so you can sub p to be equals to x minus x squared, right? So this is the one that we will need to sub in. And where do we sub in? In the results over here. Okay, so let's do the subbing. So over here we have a 64 plus 192 of x minus x squared, like this, plus 240 x minus x squared, then outside we have a square, like that. Okay, can. So let us slowly expand this first and we see how it works. So 64 plus 192x minus 192x squared. Now this one, let us do the square. So we are going to have 240 x squared minus 2x cubed plus x power 4. Okay, now then you can expand and simplify, okay? But I think we just cut to the chase. We are going to look for the coefficient of x squared, right? Coefficient of x squared. So the coefficient of x squared is over here, right? The x squared term is actually over here. Okay, so here therefore, so coefficient of x squared is going to be negative 192 plus 240. So this would be 48. So the first one answer 48. Okay, so there goes the first one. So what it really means is so even the first part is that you need to know the formula for your binomial theorem, and you need to know when to use it. So you need to answer the question, what is the formula, why do you need to use it? Okay, otherwise you're going to be stuck and you don't know how to do it, even though the concept is rather repetitive. Like once you do many times, you really know what to do already. Okay, so you have to know the formula, you have to know why do you use and when do you use the formula. Okay, so yes, you have to do a little bit of thinking from here. And then when do we use the formula? We use it when we expand. So during the expansion, we need to look for different r's. We need to sub in the different r's to expand, okay, all the way to r6. If you are looking for a specific term, then it will be like the next question that we will see later. Okay, question 2. So like what we mentioned earlier, we are looking for the term independent of x. So over here, we are looking for a specific term. Okay, and which is the term independent of x? It is the constant term, or the term where the power of x is 0. Okay, so this one, or the constant term, okay, in the expansion of this whole thing. So how do we do this? Now, instead of expanding one by one, what I will encourage you to do is to make use of the formula to find the general term. Just find one term. Then we need to do something. So over here, because we're looking for a specific term, we make use of the general term. Okay, so general term tr plus 1 is going to be equals to n choose r. So over here, n is 12, r we don't know, right? And then the a to the power of n minus r, and the b to the power of r. So it's really just using this formula over here. But now there are some tips and tricks for us to get used to. Okay, so let's see what is it. First one, 12 choose r, no choice, we leave it there first. Next one, now because we want to make it a polynomial, so all the coefficients, right, all the coefficients to the left, all the x's to the right. Okay, so what I need to do is I need to split out the coefficient and the x so that I can group left and right. Okay, so what do I have over here? I have a 2 and an x, so this would be 12 minus r, 12 minus r, using the law of indices. Then over here, right, this one I can split it to negative half, and I have a 1 over x squared, like this. Okay, including the negative, very important. The negative important must be there. Okay, must be inside the bracket. Okay, so that is easier to collapse. Okay, so now let's flush all the coefficients to the left. So 12 choose r, 2 to the power of 12 minus r, negative half to the power of r. So this is what we did earlier. Okay, and the next one will be x to the 12 minus r, and this one over here is x to the power of negative 2r. Okay, can see how this works. Alright, so now the coefficient in front, I'm just going to leave it there. Okay, the coefficient in front, I will just leave it there. Now the x at the back, this is 12 minus 3r all together. Okay, now so for us to get a constant term, or the x0 term, the power over here, you see, observe, the power over here must be 0. So for the term independent of x, right, the power 12 minus 3r is going to be equal to 0. Now solving for r will be equals to 4. Okay, so we are not asking for the fourth term, the fifth term, we are asking for the term itself. So we need to sub back and to find the term. So the term is actually term 4 plus 1, so means term 5. Okay, 4 plus 1, r plus 1, so 4 plus 1, so this is term 5. So this is going to be equals to, okay, so 12 choose 4, r is 4, So I have a, okay, if you want to use this also can, if you want to use this also can, up to you. For me, I'm just going to go with the latter one, easier to do. So I'm with a 2, 12 minus 4, okay, and I have a negative half to the power of 4, and then over here this would be x to the power of 12 minus 3 times 4. So lo and behold, that one will become x power 0, and this one will fade away. Okay, x power 0 will be equal to 1. So using your calculator, 12 choose 4. 12 choose 4 times 2 to the power of 8 times negative half to the power of 4. So your calculator will give you 7920. So 7920 is the constant term, or the term independent of x. Okay, so meaning x, there's no x. Okay, there will be something x, something x, something x, right? Then in the middle, term number 5, there will be a 7920 without any x. So that's the term independent of x. Now part B, in the binomial expansion of 1 plus kx power n is greater than 2, k is a constant. Now the coefficients of x squared, x and x squared are equal. Okay, so we need to show something. Okay, so let us expand for part B. Okay, so part B over here. So now I'm expanding 1 plus k x to the power of n. Now, so with this one over here, because I need to expand. In the binomial expansion, I need to expand. So if I expand, I need to use the general formula repeatedly. So this will be an n choose 0 of 1 to the power of 0, and 1 to the power of n minus 0, which is n, and kx to the power of 0. Okay, next one, plus n choose 1 to the power of n minus 1, and kx to the power of 1. Okay, next one, n choose 2 1 to the power of n minus 2, and I have a kx to the power of 2, right, and so on and so forth. I think we just do this enough, because I already have my x term and my x squared term. I just need to expand until there. Okay, so let's do some simplifying. So n choose 0 is 1, 1 to the power of n is 1, 1 to the power of anything in fact is 1, anything to the power of 0 is also 1, so this first term is 1. Next one, n choose 1 is going to be n, so this is a special result that you need to know. 1 to the power of anything is 1, kx to the power of 1 is just kx. Okay, plus, now n choose 2, you need to remember the special result. The special result for n choose 2 would be n minus 1 over 2. Okay, next one, 1 to the power of anything is going to be 1. Right, kx squared, let's expand, so k squared x squared, don't forget k squared x squared. Okay, so let's simplify. So the first term is 1, second term will be n kx, the third term would be n minus 1 over 2, right, and I have a k squared on top and a x squared over here. Alright, so given that the coefficient of x are so given, right, so now I think we're done already. So given coefficient of x is equals to the coefficient of x squared, right, because we've done our expansion already, so let's compare the terms, this one and this one over here. So these two are going to be equal, so nk is going to be equals to n minus 1 over 2 times k squared, like that. Okay, so then what we can do from one glance, because we can look at the left and the right to balance, right, so we can cancel n, right, we can cancel n, we can also cancel k, then we bring the 2 up. So over here I have a 2, okay, I can bring the 2 up like this to multiply on top, cross multiply. So 2 is going to be equals to n minus 1 times k, right, and we want k to be the subject, so I'm just going to throw everything else to there. So 2 over n minus 1 is equals to k, so last but not least, k equals to 2 over n minus 1 shown. Okay, so rather now it's not difficult. Okay, so this one, don't worry too much, it's not going to be difficult, but you need to know the general term, and you need to know when to use the general term. Okay, so when we expand, we use the general term repeatedly. If we look for the term independent of x, or when we look for a specific term, then we use the general term just for that case. And we need to solve for the power, solve for r. Okay, so that brings us to question 2. Okay, question 3. So find in ascending powers of x the first 4 terms of the expansion. So we need to expand. We need to expand for the first 4 terms. And then hence find the value coefficient x squared in that expansion. Can, no problem. So let's expand the first one. We expand this one over here, right? And then take note of first 4 terms. Okay, so I have a 1 minus 3x to the power of 9. Okay, so this would be okay, so repeatedly, okay, n choose r, a n power r, b power r. So let's do this. So n is 9, right? R we are going to roll. First term 1 to the n minus something. Second term would be negative 3x, like that. Okay, so I'm just going to copy and paste 4 times. Okay, so I want you to see this. It's actually very straightforward. It's just repeating and repeating and repeating the whole process again and again and again. Okay, so let's see. Okay, so let me okay, wow, just nice can fit. Okay, so let's put the power in. So this will be 0, right? This is 1. So you just need to see that it's actually a rolling thing going on, right? And choose 3, 3, 3, just like that. Very simple. Okay, so then 9 choose 0 is 1. 1 to the power anything is 1. 3x to the power anything is 1. Just like that. Okay, next one. 9 choose 1 is 9. 1 to the power anything is 1. Then negative 3x will be negative 3x, like that. Okay, next one. 9 choose 2. So calculator. 9 choose 2 is going to be 36. 1 to the power anything is 1. So then negative 3x squared will be a 9x squared, because squared. Okay, then 9 choose 3 is going to be 84. Right, 1 to the power anything is 1. So negative 3 cubed would be negative 27. X cubed would be x cubed. Okay, so that's yeah, continuous. Okay, so let's simplify. So 1 minus 27x plus 324 x squared plus 84 times 27, or more, minus 2268x to the power of 3, like that. Okay, so like that. So be careful of the positives and negatives where you expand. Okay, otherwise I think, yeah, you should be fine. Okay, next one. Hence find the coefficient of this. So we have 3x minus 5 minus 9 over 4x. This would be 1 minus 3x over 9. Okay, so over here you observe this is actually this, right? Same part. So actually we can replace this one with this expanded form over here. Okay, we can do the replacing over here. So let's see. So we have a 3x minus 5 minus 9 over 4x, and then we have a 1 minus 27x plus 324x squared minus 2268 to the power of x cubed, and so on and so forth. Okay, so do we need to, okay, then hence find the coefficient of x squared. So we just need to find the coefficient of x squared. So then the next question is, do we need to expand everything to find the coefficient of x squared? Don't need to. Okay, so what we can do is we can just choose the things to multiply together so that we can get our goal. So the first one will be 3x and negative 27x. So x times x will give me x squared, right? Now, next one, the 5 and 324x squared. So this is my second x squared term. Now my third x squared term will be over here. Okay, the third x squared term will be a bit fresh because it will be like this, you see. Now, why did I choose an x cubed term, right? So something x cubed, right? Over here, do you see this? Divided by x. right? So when 9 over 4x times 226x cubed, so this and this will cancel, it become x squared. Okay, so that this is what we'll be aiming for. Okay, so do we need to write everything out? Don't need. Okay, I will just do this. Coefficient of x squared would be first one. Okay, the first one. So 3, this one. 3 and negative 27. So I have a 3 times negative 27. Next one over here, I have a negative 5 and 324, right? So minus 5 and 324. Last one, I have a negative 9 over 4 times negative 2268. So negative 9 over 4 times a negative 2268. So let's add all of this together. So total would be 3402. Okay, so this will be our final answer. So once again, we don't need to expand everything. We just need to look at which terms will give us the x square term. Okay, so that's basically it. Okay, so let's look at question 4. Question 4, we are solving each of the following equations. So over here, right, A is going to be a special kind of equation. So if you notice this, right, if you've seen enough, if you've practiced enough, right, you can very well see that this is a quadratic equation, right? But otherwise, you're going to think, okay, so what are the strategies available for indices? So usually the common strategy would be to use common base, then we can work the law of indices. We can use common index, and then we can combine the base together, right? Now, then there's also logarithms if we have, but the problem is this one is a plus, correct? And we can't do much with plus. Do we have anything to factorize? Do we have anything to factorize? Not so much, right? So the only thing that we can think of is maybe the last case would be this is a quadratic equation, and or we will need to make use of a suitable substitution to do this. Okay, so this is the thinking process for this question law. Okay, so it is to maybe look at a suitable substitution, because we can't really use law of indices over here. Okay, so what can we do over here? I have a 3 to the power of 2x. Now then I need to split this up so that I can really see what this is. So you'll have a 3 cubed over 3 to the power of 2x. This is going to be equals to 12. Okay, so just nice, I have something already. I have my 3 power 2x, and I can actually use a smart substitution to sub these two things. So what do I do is I will sub u to be 3 to the power 2x, or let this to be 3 power 2x. So I will have a u plus 27 over u equals to 12. Multiply whole thing by u throughout. So over here I have a u times u square. 27 over u times u will be 27. 12 times u will be u, 12u. Okay, don't forget the 12. So u square minus 12u plus 27 is going to be equal to 0. Factorize. So minus 9 u minus 3 equals to 0. So u is equals to 9, or u is going to be equals to 3. So back to this one. So 3 to the power of 2x is going to be equals to 3 square. Alright, right in index mode. So the last so the last thing to write over here would be 2x equals to 2, x equals to 1, like that. Okay, next one, u equals to 3. So which means 3 to the power of 2x is going to be equals to 3 power 1. So last step, 2x equals to 1, so x will be equals to half. Okay, and this is how we solve the final bit to bring back the 3 power 2x. Okay, so just nice, quadratic equation. Now let's look at B. B is a bit weirder. B, we have a 9 power x, and then we have a double square root. Okay, so what can we do is, inside, take note, this is 3 times root 27. If it's a cube root, the font would be much smaller for the 3, so be careful. Okay, so so the first out, so when we take out the square roots, we need to start from the outside. So means I will need to square both sides, correct? Square both sides, so I have a 9 to the power of 2x, then this will be 3 to the root 27, like that. Okay, now then let's do one more round, because there's one more square, right? There's one more square root, so let's square one more round. So when we square one more round, will be 9 to the power of 4x is equals to 3 square is 9, root 27 square is 27, like that. Okay, so let's do this. So let's do this in base 3. So that base 3, right, I can write 9 as 3 square, then power 4x. Then the next one, 9 is going to be 3 square, 27 is 3 to the power of 3. So altogether, 3 power 8x is equals to 3 to the power of 5. So now comparing the index, because now the base is the same, right? Comparing index, 8x is equals to 5. X is equals to 5 over 8. So we solve like that. Okay, so the strategy is compare same base, compare same, we get the same base or we try to get the same index. For this case, we'll be getting the same base, then compare index. So mainly like that. And when we've exhausted all options, all the law of logarithm that we cannot use, or law of indices that we cannot use, maybe it will be a quadratic equation like what we have on the A. Okay, so that's about it for question 4. Okay, so we skip question 5 because question 5 are certs. We are not testing certs for this WA, so let's skip that. Now, then let's look at question 6. Now, 6a means logarithm. So it means we're going to have a bit of fun with the logarithm. And A, right? Now, A, don't panic because even though it looks a bit hideous, technically these are values that you should learn already. Okay, so just in case, if you cannot do anything, just in case, what you can do is you need to change the base. So how to change the base? So change base to ln 81 over ln 3. Change to a natural base, or you can change to LG also can, up to you. Okay, this would be a ln 125 over a ln 5, right? This one plus ln 8 over ln root 2. Then type everything in your calculator, you should get a final nice answer. But this one will be last resort. Will be the last resort. Now, the thing is, for this question, right, the concept of logarithm is important. So the first question is, what are logarithms? Logarithms are powers. So it answers the question to 3 base, right? Base 3 to the power of what is 81. So 3 to the power of what is 81? 3 to the power of 4 is 81. So you need to answer this question. Okay, so whenever you think about logarithm, you must think of powers. Think in terms of powers. Next one, 5 to the power of what is 125? 5 to the power of 3 is 125. Okay, next one, if cannot, let's make use of law change of base rule. Okay, because I have a root 2 and 8, right? So the common base would be log base 2. Okay, log base 2 of this. Okay, so let's do this. So 4 minus 3 is 1. Okay, or more like I will keep the 4 first. 4 minus 3 first, then plus. Okay, so log base 2 power 8, this would be 2 to the power of 3 is 8. And 2 to the power of what is root 2? 2 to the power of half is going to be root 2. Okay, so let's do the final bit. So the final bit will be 4 minus 3 plus 3 divided by half. So answer is 7. Okay, easy. Okay, very easy. So for part A, it's just evaluating, right? So you just need to understand what is the meaning of your logarithms. Okay. Now for part B, it will be a bit challenging because you don't start with easy bases, and then you have many bases to handle. Okay. So like the advice that I gave just now, right? If all else fails, if everything fails, do the change of base formula to ln or log 10. Okay, log base 10. Okay, now the thing for us is, now if you're using photomath or if you're using some random app, they may tell you that you can write 9 square and 36 9 and 36 as 3 square and 6 square. But the thing is, right, for the law of logarithm that we've learned so far, we've never done anything with converting the base to a square, but we have done change of base. So 9 and 36, right, you need to make a choice over here. Okay, you need to make a choice. So the 9 and 36, right, because 36 is a composite number, so it will be good if you can split the 36 up as a product of two numbers. So 36, I'm going to split up as 9 times 4. 9 times 4, 36, right? So let's do that. Next one, log base 3 of 2. This one no choice. I will go leave it here first. Now, then log 0.504. 4 is 4. 0.5 is half. So they have a common base 2. So I'm just going to change the base to base 2 for this one over here. Log base 2 of half, like that. Okay, so next, using the law of logarithm, so the first one will be log 9, log base 9 of 9 plus log base 9 of 4 minus log base 3 of 2 plus, now log base 2 of 4, 2 to the power of 2 is 4, 2 to the power of negative 1 is half. Okay, you see this? Okay, one more time. 2 to the power of 2 is 4, right? 2 to the power of negative 1 is half. Because half, I can write this as 2 to the power of negative 1. Okay, so they're just asking us what power is that. Now next one, log 9 is going to be equals to 1. Log 9 4 a bit sad, right? But you remember that there's a log base 3 beside it? Do you remember this log base 3 over here? So why not let's follow this. Let's change this to log base 3. Okay, so plus log base 3 of 4. Then this would be log base 3 of 9 minus log base 3 of 2 minus 2. Okay, so next one over here, so 1 plus, now log base 3 of 4, this would be log base 3 of 2 square. Okay, now divided by log base 3 of 9, 3 to the power of 2 will be equals to 9 minus log base 3 of 2 minus 2. Next, so 1 plus, now then I will make use of the power rule, so bring the 2 in front, so 2 log base 3 of 2 over 2 minus log base 3 of 2 minus 2. Then these 2 and these 2 can cancel, so I have a 1 plus log base 3 of 2 minus log base 3 of 2 minus 2. Okay, then last but not least, these two, because 1 plus 1 minus, I can cancel them off again. And then last but not least, 1 minus 2 would be negative 1. So the negative 1 would be my final answer for this question B. Okay, so B looks a bit longer precisely because we don't have a simple base to begin with. But the thing is, we can always change to a simpler base. For example, 9, we can always change to base 3. For 4 and half, we can always change to base 2. Alright, so changing bases will help with this question over here. Okay, so question 7 over here tells us to use to solve the following simultaneous equation. So let's do this. So we have two equations. So we start off with an e square root of e power x is equals to e power 2y. So e is a special number, right, to denote the natural growth of an object. And then the second simultaneous equation would be log base 4 of x plus 2 plus, okay, equals to 1 plus log base 2 of y. Okay, so let's do this. So at first we are going to have a, okay, so for simultaneous equation involving logarithm and indices, right, the extra bit is just the logarithm and indices. So what we need to do is we need to get rid of all the distraction so that we'll filter out to only x and y. Okay, we don't sub in when it's like raw form because sometimes it may get a bit too complicated. We sub in when it is a bit more convenient. So we need to do some tidying up first. So the first one over here will be e power 1 and e power half x because square root is half. Okay, and then we have an e power 2y. So let's push one more step further. E to the power 1 plus half x is equals to e to the power of 2y. So then comparing indices, 1 plus half x is equals to 2y. So 2 plus x, everything times 2 will become 4y. So x is equals to 4y minus 2. So this is equation 1. Okay, so everything times 2 over here. Okay, so then I have an equation tidy up already. So second one, so over here I have a log base 4. So why not I change it to log base 2 to make my life easier. Okay, so I have a log base 4, or log base 2, sorry, log base 2 of x plus 2 over log base 2 of 4. So change of base formula on the left. Now 1, I can write this as log base 2 of 2, right? Then this one would be log base 2 of y. Okay, then on the left hand side I need to evaluate a bit, on the right hand side combine. So this one over here is 2, so what I get over here would be half log base 2 of x plus 2. Okay, it's going to be equals to log base 2 of 2y. Okay, this will be the law of indices. So when I have a plus, I can combine it as a product. Last but not least, let me put the half up there. So x plus 2 to the power of half. Okay, or more like if you don't want to put the half, you actually put the square root x plus 2. Right? Effectively, this is half. Equals to log base 2 of 2y. Right? Then we can remove the log on both sides because we are comparing the content. So then, therefore, we get something like this. Okay? And we have, if we square both sides, it will be like this. Don't forget the 2 square, it will be like this. Okay, so this is equation 2. So with this in mind, so let us sub in equation 1, sub into equation 2. Okay, so I have a x plus 2 is equals to 4y squared, right? And then just nice x will be 4y minus 2. Okay, so over here on the left, I have a 4y over here. Minus 2 plus 2 is 0. On the right is just 4y squared. Now then I can divide by 4 on both sides. So over here 0 is equals to y squared minus y. So how do we solve this? Factorize. So y minus 1. Okay, so it's either y equals to 0 or y equals to 1. Okay, and let's check this with our answer above. So over here, y can be any power because e can be any power, right? Now this one over here, y, log 2y, right? We need to check. So over here, 2 to the power of what is 0? A bit impossible because this one has to be greater than 0 for this solution to be valid. So this y we have to reject because y must be more than 0 from the logarithm. Okay, then so remember to check back to the original equation. Okay, so then from equation 1, so x will be equals to 4y minus 2, so x will be equals to 2. Okay, so y equals to 1, x equals to positive 2. So both are positive numbers, right? So let's double check and see. Now this one over here, 2 plus 2 will give you 4, right? So log 4 just nice will give you a good number. This one over here, the x can be any number, so it's fine. Okay, so the final answer, y equals to 1, x equals to 2. So don't forget to check your final answer with the original equation. And one more time, the strategy for simultaneous equation is to strip this away from the base so that you get the raw form, to strip this from the logarithm so that you get this without the logarithm. Then you can solve this easily and nicely already. Otherwise, you'll be trapped in that logarithm or trapped in the index and you can't move out. So the goal is to remove logarithm, remove index if possible. Okay? Okay, question 8. So question 8, we are going to solve equations like this. So the first one is in index form. So I have a 3 power 1 minus 2x plus 2 is equals to 7 over 3x. Now this one over here, right, a bit difficult because, right, we are seeing like we have a plus 2 randomly, we have a 7 there. So it's a bit impossible for us to combine the combine bases, then add the index, and we a bit hard to apply law of indices because we need common bases, right? So a bit hard to do so. So instead, we need to explore suitable substitution. Okay, so what substitution do we need? Let's try and see. So over here, 3 power 1 minus 2x will be 3 power 1 minus will give me an over something. So 3 to the power of 2x like this. Okay, plus 2. Okay, then this will be equals to 7 over 3 power x. Okay, so what I can do is, now I can substitute. okay, u to be equals to 3 to the power of x, and then we can see how it works. So the first one over here is 3 over, now this one I can rewrite this as 3x square. Can see 3 power x square, right, by law of indices, 3 power x square. So then this would be my u square over here, okay. So then plus 2 is equals to 7 over u. So then I multiply everything by u square to get rid of the denominator. So the first one will be 3, second one is 2u square, the third one will be 7u. Okay, 7 over u times u square, 7u. Rearrange, so 2u square minus 7u plus 3 equals to 0. Now then we can do the formula, okay, we can factorize. So 2u and u, 3 and 1 minus minus. So u would be equals to half, or u would be equals to 3, right? So then the next thing is over here. Okay, so sub back the 3x will be equals to half, okay, and 3 power x will be equals to 3 power 1. So on the right, very nice, x is equals to 1 when you compare indices. But on the left, right, a bit difficult. So what we can do is, there's two ways to do this. Because we don't have a common base, we can take the ln of both sides. Okay, we can do the ln of both sides. Then x ln 3 by the law of indices, law of logarithm, will be this. Okay, one more step over here. X would be equals to ln half over ln 3. So this is one way to do it. Okay, now the second way to do it is, now because we are doing logarithm, we are doing like indices, how do I reverse the index? How do I get rid of the base? So the base on the left would be log base 3 on the right hand side, like that. Okay, and then I can need my help with the calculator, so I need to change the base to a natural log, half on top, then ln 3 natural log below. Okay, so it is very similar to what we did the step before. Okay, so this gives us negative 0.631 to 3 significant figures, like that. Okay, so this would be part A. Okay, so one more time, the last part over there. For the very last part is, now there's two ways that you can do it. You can take log of both sides or ln of both sides, bring the x down, then get rid of the ln 3. Or you can make use of the equivalence, like how to change index form to logarithm form. Then because base 3 on the left will become the log base 3 on the right. Okay, so mainly like that. Okay, let's look at B. So B over here, right, we have a 3 log base x of 3 equals to 8 minus 4 log base 3 of x. Now notice log base x of 3, log base 3 of x. So we can do something about it. So if you remember the shortcut, okay, if you remember the results, log base x of 3, if I want to swap the order of these two things, this will be 1 over log base 3 of x. Reason because I can change this to log base 3. So on top also log base 3, this would be 1. Okay, so like that. So the simple the shortcut would be 1 over log base 3 of x, then equals to 8 minus 4 log base 3 of x. Now then I need to figure out, so like if you try the next few steps, right, technically you'll be a bit it's a bit exhausted, like you exhaust all the ways to, like you need to find a way to combine all the logarithm, which can be done actually. Should I try doing it? Oh, a bit difficult also lah. Yeah, a bit difficult to like combine everything together because one is below, one is on top, right? A bit difficult to do so. So what can we do instead to help us? We can also learn from index. We can make use of smart substitution. So over here, what do we substitute? Substitute u to be equals to log base 3 of x. Okay, so once we exhaust all the law of logarithm or all the possible common base and for logarithm, that kind of thing, right, we can make use of substitution, smart substitution. So what is this? This would be, now 3 over u equals to 8 minus 4u, right? So there's a divide by u at the bottom, so we just need to times u. So 3 equals to 8u minus 4u square. So rearrange. Okay, rearrange like this. So I have a feeling this will not be like, okay, we can factorize. So this will be 2u minus 3, 2u minus 1. Okay, like that. So u will be equals to 3 over 2, or u would be equals to half. Okay, so then let's do this. So I have a log base 3 of x is equals to 3 over 2. Log base 3 of x will equals to half over here. Okay, right? Because we sub this as log base 3 of x, right? So we get back this. Okay, so because this is 3 base log base 3, right? So if we were to put on the right hand side, this will be base 3 also, but power 3 over 2. Okay, power 3 over 2. Okay, then the next one, x log base 3 on the left becomes base 3 on the right, 3 power half. So this is the square root of 3, right? So let's find the answer in 3SF. So this would be 1.73 to 3 sig fig. This one, root 3, would be also 1.73. Sorry, the other one a bit wrong. This should be 3 to the power 1.5. So this 5.20. Yes, this makes more sense. Okay, so 5.20 and 1.73. So once again, if you have exhausted all the law of logarithm, then we can consider a good substitution. Okay, second last question for this set. Given that series of log equals to y, express x in terms of y. So we want x to be the subject. Okay, making x the subject. So let's do this. So this one, right, it requires a simple trick actually. Okay, so for this one, it's actually just a tricky question, but nothing that we cannot do. So all would be fine. Okay, so the trick is, because everything is in different base, so we just change to a common base. So that like that. So we just need to change to ln 3 over ln 2. Then I have a ln 4 over ln 3. Then I have a ln x over ln 4. Right? So this one will be equals to y. Now then we can see a series of cancellation already. You can cancel this. You can cancel the 4. So it is just ln x over ln 2 equals to y. Okay, so because ln x and ln 2, right, we can make use of this and convert back. So it's a reverse change of base law. So we can convert back to log base 2 of x is equals to y, right? The reverse change of base rule, and will be log base 2 on the left. So x as a subject will be base 2 on the right. So base 2 of y. So this is just express x as a subject. So remove the log base 2 from the left. Okay, so mainly like that. Okay, last question of the day. So now this one will relate to the graph of logarithm. So must know the shape of the graph. So sketch the graph of the function y equals to ln x. Can. So y equals to ln x would be looking something like this. Right, so something like this. And then I have a curve like this. Curve like that. Right, cut at 1. So this is y equals to ln x. Ln of x. X and y, 0. Okay, number 2. So number 2, express this e power 4 minus x in the form of ln x equals to ax plus b. Right, so actually this gives us a glimpse into the next chapter already. Right, but what do we need to do is we need a ln x. We need a ln x. So technically speaking, we can ln both sides. right? We can ln both sides over here, right? And over here, right, I have a 2 ln x, and then ln e, right, because they are the same base. So technically, this would be our answer, 4 minus x over here, okay? Now, otherwise, the second way to do this is, because I want a ln x on the left, and the ln is actually base e. So means I want my base e to be on the left. So how do I move from the index base e to the left? This would become my log base e of x squared. So log base e would be ln x squared. Then on the right, the power just come down. Okay, so this would be 2 ln x using the law of indices. Law of logarithm, the power law. So last but not least, ln x will be equal to 2 minus half x. Okay, or if you want to be a bit more like minus half x plus 2. Okay, so you will follow this form at the end. So a is negative half, b is positive 2. Okay, so part 3, insert your sketch the additional straight line required to obtain a graphical solution. So from here, right, from here we have transformed into this. We have transformed into this form, right? So technically speaking, right, what is ln x? Because we've already drawn y equals to ln x, already drawn this. So what is this? This now becomes our y. So y is equals to this. So what we need to do is we need to draw this graph. And what graph is this? This is a straight line graph, negative gradient cut at 2. Okay, so negative gradient cut at 2. So roughly like this. Okay, cut at 2, negative gradient. So y equals to negative 1 over 4 x plus 2. So that this point over here, this point over here is a graphical solution to the equation over here. The intersection, point of intersection, will be our graphical solution to that equation over there. Okay, so this is all for set A, and woof, it has been a very long hour. So hope this is enriching. Hope you've get a bit of insights and a bit of strategy on how to tackle questions like this. Okay, so see you in the second video.